Hey everyone! Welcome back to our channel. Today we're diving into one of the most mesmerizing phenomena in the sky, solar eclipses. Have you ever wondered how they occur, why they're so rare, and what makes them such an incredible spectacle? Well, you're in the right place. In this video, we're going to break down the science behind solar eclipses, explaining everything you need to know, from the mechanics to the different types. By the end of this video, you'll have a deeper appreciation for this cosmic event. So, let's get started. What is a solar eclipse? A solar eclipse occurs when the moon moves between the Earth and the Sun, blocking sunlight from reaching certain parts of Earth. This alignment results in the moon casting a shadow on Earth, either partially or fully covering the Sun from our perspective. Solar eclipses can only happen during a new moon, but not every new moon brings an eclipse. The alignment has to be precise, with the Earth, Moon, and Sun positioned perfectly in a straight line. This rare event is a remarkable display of cosmic harmony, reminding us of the intricate dance happening within our solar system. The three main types of solar eclipses. There are three primary types of solar eclipses: total, partial, and annular. A total eclipse occurs when the moon completely covers the sun, leading to a dramatic, temporary darkening of the sky. A partial eclipse happens when only a portion of the sun is obscured, creating a less intense but still fascinating visual. Lastly, an annular eclipse happens when the moon is farther away from Earth, making it appear smaller than the sun. This results in a ring of fire, where the sun's outer edges remain visible around the moon. The rarity of solar eclipses. Solar eclipses are rare due to the precise alignment required between the Earth, Moon, and Sun. The moon's orbit around Earth is tilted relative to Earth's orbit around the sun, meaning most new moons don't result in an eclipse. Additionally, total eclipses are even more infrequent because the path of totality, where the sun is completely covered, is very narrow. Most places on Earth experience a total solar eclipse only once every 360 to 410 years. This rarity contributes to the excitement and intrigue surrounding solar eclipses. The shadow cast during a solar eclipse. When a solar eclipse occurs, the moon casts two types of shadows on Earth, the umbra and the penumbra. The umbra is the darkest part of the shadow, where the sun is completely obscured, resulting in a total eclipse for viewers in this region. The penumbra is a lighter, outer shadow where only a portion of the sun is blocked, creating a partial eclipse. Depending on your location within these shadows, you'll experience a different type of eclipse. The gradual movement of these shadows across Earth during the eclipse creates the visual experience we observe. Solar eclipses and scientific discovery. Solar eclipses have played an important role in scientific discovery. One of the most famous examples is the confirmation of Albert Einstein's general theory of relativity in 1919. During a solar eclipse, astronomers were able to measure the bending of starlight around the sun, an effect predicted by Einstein. The eclipse provided the perfect conditions to observe this phenomenon, as the sun's light was blocked, allowing the faint starlight to be visible. Eclipses continue to offer opportunities for scientists to study the sun's outer atmosphere, known as the corona, which is normally hidden by the sun's bright light. Eclipse cycles, the Saros cycle. The occurrence of solar eclipses follows a predictable cycle known as the Saros cycle, which lasts about 18 years, 11 days, and 8 hours. This cycle is based on the alignment of the Sun, Moon, and Earth. After one Saros cycle, a nearly identical solar eclipse will occur, with the same geometry and in a similar location on Earth. This cycle helps astronomers predict future eclipses with great accuracy, though the exact path of totality shifts slightly with each new event. The Saros cycle was known to ancient civilizations, who used it to anticipate eclipses. Total solar eclipses, the most spectacular type. A total solar eclipse is often regarded as one of the most awe-inspiring natural events. During totality, the day suddenly turns to night, stars and planets become visible, and the temperature can drop significantly. The sun's corona, a glowing halo of plasma surrounding the sun, becomes visible as the moon completely blocks the sun's bright disk. This dramatic shift in the environment and the eerie darkness make total solar eclipses a sought-after spectacle. However, the path of totality is usually narrow, and total eclipses last only a few minutes, making them a rare and precious event. The path of totality explained. The path of totality is the narrow region on Earth where a total solar eclipse can be observed. It typically spans a distance of a few thousand kilometers, but is only about 160 kilometers, 100 miles, wide. Only those within this path will experience the sun being completely covered by the moon. Outside this path, observers will see a partial eclipse instead. The path of totality moves across Earth as the moon's shadow travels, meaning different locations experience totality at different times. This movement, combined with the rarity of eclipses, is why some people travel great distances to witness totality. Why eclipses can't be seen everywhere. One of the most intriguing aspects of solar eclipses is that they aren't visible from everywhere on Earth. The reason lies in the geometry of the Earth, moon, and sun. The moon's shadow is relatively small compared to Earth, meaning it only covers a limited area during an eclipse. As a result, only people located within the shadow's path can observe the eclipse. Even then, not everyone in the shadow will experience totality, as the type of eclipse varies depending on one's exact position within the shadow. The annular solar eclipse, the Ring of Fire. An annular solar eclipse is sometimes referred to as the Ring of Fire eclipse because of its unique appearance. This type of eclipse occurs when the moon is farther away from Earth in its elliptical orbit, making it appear smaller than the sun. As a result, the moon does not completely cover the sun, leaving a bright ring of sunlight around the edges. While not as dramatic as a total solar eclipse, annular eclipses offer a breathtaking view, with the sun's fiery ring contrasting against the darkened sky. The term annular comes from the Latin word for ring, annulus. Partial solar eclipse, a subtle phenomenon. A partial solar eclipse occurs when only a portion of the sun is covered by the moon. Unlike a total eclipse, the sun's bright surface remains visible, creating a crescent-like shape. The sky doesn't go completely dark during a partial eclipse, but there is a noticeable dimming of light, especially during the maximum coverage. These eclipses are much more common than total solar eclipses and can be viewed from a larger area. While they may not have the dramatic effects of total eclipses, they're still fascinating to observe and provide an excellent opportunity to witness the mechanics of our solar system. Hybrid solar eclipse, a rare combination. A hybrid solar eclipse is a rare and unique type of eclipse that transitions between a total and an annular eclipse. Depending on where you are along the path of totality, you might experience the eclipse as either a total or an annular event. This happens because of the curvature of the Earth and the varying distances between the moon and different points on Earth's surface. Hybrid eclipses are less common than other types, occurring only a few times each century. Their unpredictability and rarity make them especially exciting for eclipse chasers. The role of the Earth's tilt in eclipses. The tilt of the Earth's axis plays a role in determining where and when a solar eclipse will occur. Because the Earth is tilted at approximately 23.5 degrees relative to its orbit around the Sun, the Moon's shadow doesn't always fall in the same place. This tilt, combined with the Moon's slightly tilted orbit, means that solar eclipses are visible from different locations on Earth and at different times throughout the year. The variability in the Earth's orientation adds another layer of complexity to predicting solar eclipses, contributing to their rarity. Cultural interpretations of solar eclipses. Throughout history, solar eclipses have been interpreted in various ways by different cultures. Many ancient civilizations viewed eclipses as omens or signs from the gods. In some cultures, they were feared as harbingers of disaster, while others saw them as moments of divine intervention or celestial balance. For instance, in ancient China, eclipses were thought to be caused by a dragon devouring the sun, and people would bang drums or make noise to scare the dragon away. In modern times, eclipses are often celebrated as awe-inspiring natural events, with scientific understanding replacing myth. Eclipse chasing, a growing phenomenon. Eclipse chasing has become a popular pursuit for many astronomy enthusiasts. Eclipse chasers, also known as umbrophiles, travel across the globe to experience solar eclipses, particularly total eclipses. Because the path of totality is narrow and the event is brief, these chasers often go to great lengths to position themselves in the perfect spot. The excitement of witnessing the brief moments of totality, when the sun is fully obscured, makes it a once-in-a-lifetime experience for many. Some eclipse chasers have witnessed dozens of eclipses, turning this passion into a form of adventure travel, predicting solar eclipses in ancient times. Before the advent of modern astronomy, predicting solar eclipses was a difficult task. However, ancient civilizations like the Babylonians and Mayans were able to predict eclipses with surprising accuracy. They relied on careful observations of the moon's movements and the repetitive patterns of eclipses, such as the Saros cycle, to forecast future events. While they lacked the tools we have today, these early astronomers were able to use mathematical calculations and celestial observations to predict when and where eclipses would occur, showcasing their advanced knowledge of the heavens. Eclipses in the modern era, tools for study. In the modern era, solar eclipses have become a valuable tool for scientific research. With advanced telescopes, satellites, and imaging technology, astronomers can study solar eclipses in greater detail than ever before. Eclipses allow scientists to observe the sun's corona, its outer atmosphere, without the interference of its bright surface. These observations help researchers learn more about solar wind, solar flares, and other solar phenomena. Eclipses also provide a unique opportunity to study the Earth's atmosphere, particularly how it responds to sudden changes in sunlight and temperature. The role of eclipses in general relativity. One of the most significant scientific breakthroughs tied to a solar eclipse was the confirmation of Albert Einstein's general theory of relativity. During the 1919 solar eclipse, astronomers were able to measure the bending of starlight as it passed near the sun, a phenomenon predicted by Einstein's theory. The eclipse blocked the sun's light, allowing the stars behind it to become visible. The observed deflection of light confirmed that massive objects like the sun can warp space-time, thus validating one of the key predictions of relativity and revolutionizing our understanding of gravity. Eclipse glasses, the importance of eye safety. It's crucial to use proper eye protection when observing a solar eclipse. Looking directly at the sun, even during a partial eclipse, can cause severe and permanent damage to your eyes. Special eclipse glasses are designed to block harmful ultraviolet and infrared rays, allowing you to safely view the eclipse. These glasses are made with a special solar filter that reduces the sun's brightness to safe levels. Regular sunglasses are not sufficient protection. In addition to eclipse glasses, there are other safe methods to observe the event, such as using pinhole projectors. Eclipse photography, capturing the moment. Photographing a solar eclipse requires careful preparation and the right equipment. If you plan to capture the event, you'll need a solar filter for your camera or telescope to prevent damage to your lens and sensor. Without proper protection, the sun's intense light can ruin your camera. A tripod is essential to keep the camera steady during long exposure shots. Many photographers also use remote shutter releases to minimize camera shake. Timing is everything, so knowing when maximum totality occurs is key to capturing the best shots. With the right setup, you can photograph the eclipse's breathtaking stages. Solar eclipses and climate studies. Solar eclipses offer unique opportunities to study the Earth's atmosphere and climate. During an eclipse, there is a sudden reduction in sunlight, which can cause a drop in temperature and changes in wind patterns. Scientists use this event to observe how the atmosphere responds to such rapid changes. Data gathered during solar eclipses helps improve models for weather prediction and climate change. Additionally, studying the eclipse's effects on temperature and air currents can provide insights into how sunlight interacts with the Earth's surface and atmosphere on a regular basis. The eclipse's influence on wildlife. Animals often react in unusual ways during a solar eclipse, as the sudden darkening of the sky can confuse them. Birds may stop singing and return to their nests. Nocturnal animals may emerge from their hiding places, and some animals may change their feeding patterns. This behavior is triggered by the rapid change in light and temperature, which disrupts their normal biological rhythms. Studying how wildlife responds to eclipses offers insights into the broader effects of environmental changes on animal behavior, as well as how animals use natural light cycles to govern their daily activities. Historical superstitions about eclipses. Historically, solar eclipses have been viewed with fear and superstition. Many ancient cultures believed eclipses were bad omens, signaling disaster or divine displeasure. Some thought that the sun was being devoured by mythical creatures. For example, in ancient China, people believed a dragon was eating the sun, and they would bang drums or create loud noises to scare it away. In the ancient Inca civilization, eclipses were seen as battles between gods. These superstitions were often rooted in the sudden and dramatic nature of eclipses, which seemed to defy the normal order of the world. The eclipse in literature and art. Solar eclipses have long been a source of inspiration for writers, poets, and artists. In literature, eclipses are often used as symbols of change, transformation, or foreboding. Shakespeare referenced eclipses in his works, using them to symbolize turmoil and chaos. In art, eclipses have been depicted in various ways, from detailed astronomical drawings to symbolic representations of light and darkness. These creative interpretations reflect the awe and mystery that solar eclipses have historically evoked. Even in modern times, eclipses continue to capture the imagination of artists and storytellers. Eclipse expeditions, past and present. For centuries, expeditions have been organized to observe solar eclipses. In the 19th and early 20th centuries, scientists and explorers would travel to remote regions to capture and study eclipses, as they provided rare opportunities to learn more about the sun and the cosmos. One of the most famous expeditions was during the 1919 solar eclipse, when teams of astronomers traveled to locations in South America and Africa to confirm Einstein's theory of relativity. Today, eclipse expeditions continue, but with modern technology, enthusiasts can plan trips with more precision to ensure they are in the path of totality. Eclipse-related scientific instruments. Over the centuries, scientists have developed specialized instruments to study solar eclipses. One of the most important tools is the coronagraph, a device that allows astronomers to observe the sun's corona even when there isn't an eclipse. This instrument blocks out the sun's bright disk, mimicking the effect of an eclipse. During actual eclipses, modern equipment like high-resolution cameras, spectrographs, and telescopes equipped with solar filters are used to capture detailed images and data. These instruments have helped researchers unlock many mysteries of the sun's behavior, such as solar wind and magnetic fields. Eclipse weather conditions. How climate affects viewing. Viewing a solar eclipse depends heavily on weather conditions. Cloud cover can obscure the sun, preventing a clear view of the eclipse. Therefore, eclipse chasers often prioritize destinations with historically clear skies during the time of an eclipse. Weather forecasts and satellite data are used to determine the best locations for viewing. In some cases, people have traveled to high altitudes or even chartered planes to get above the clouds for an unobstructed view. Having the right weather conditions can make or break the experience of viewing a solar eclipse, adding an element of unpredictability to the event. The eclipse's impact on technology. Solar eclipses have influenced the development of various technologies, particularly in photography and imaging. Early photographers faced the challenge of capturing the brief moments of totality, and their efforts led to improvements in camera technology and exposure techniques. In the modern era, spacecraft and satellites have been designed to study the sun, with some missions specifically targeting solar eclipses. For example, NASA's Solar Dynamics Observatory provides real-time images of solar events, including eclipses. The advancement of these technologies has enabled scientists to capture unprecedented details of solar eclipses and their effects on Earth. Solar eclipses in modern pop culture. Solar eclipses have made their way into modern pop culture, appearing in films, television shows, and novels. They are often portrayed as dramatic, mystical events that signal major turning points in a story. In movies like Apocalypse Now and Lady Hawk, solar eclipses are used as plot devices to create tension or signify change. Eclipses have also appeared in science fiction, where they are sometimes depicted as events that unlock hidden powers or reveal hidden truths. This fascination with eclipses in popular culture reflects our enduring sense of wonder about these celestial events. The role of eclipses in education. Solar eclipses are an excellent educational tool for teaching about astronomy, physics, and earth science. Schools and universities often organize viewing events, and students can engage in hands-on learning by building pinhole projectors or using telescopes with solar filters. Eclipses also provide opportunities to discuss topics like orbital mechanics, the movement of celestial bodies, and the scale of the solar system. In addition, these events can spark interest in STEM fields, inspiring future generations of scientists, engineers, and astronomers to explore the mysteries of the universe. Eclipse viewing safety tips. Viewing a solar eclipse can be a thrilling experience, but safety should always come first. Looking directly at the sun, even during a partial eclipse, can cause serious and permanent eye damage. To safely observe an eclipse, it's essential to use proper eye protection, such as eclipse glasses with ISO certification or welder's glass rated at shade 14. You can also use indirect methods, like a pinhole projector or a solar viewing filter on a telescope or camera. Ensuring you have the right equipment will allow you to enjoy the eclipse safely without risking your eyesight. The next total solar eclipse. If you missed the last solar eclipse, don't worry. Another one is always on the horizon. The next total solar eclipse is predicted to occur on April 8, 2024, and it will be visible across parts of North America, including Mexico, the United States, and Canada. Known as the Great North American Eclipse, it's expected to attract millions of eclipse chasers and astronomy enthusiasts. This eclipse will last for up to 4.5 minutes, offering a longer totality than most. If you're planning to witness it, now's the time to start preparing your viewing location and gear. The eclipse's effect on solar power. Solar eclipses have a temporary but significant effect on solar power generation. As the sun's light is blocked, solar panels generate less electricity, which can impact power grids, especially in areas that rely heavily on solar energy. During the 2017 total solar eclipse in the United States, energy companies prepared for the drop in solar output by using other energy sources to fill the gap. While the eclipse's effect on solar power is brief, it highlights the importance of having a diverse energy grid that can adapt to sudden changes in sunlight. Eclipses as a cosmic coincidence. One of the reasons solar eclipses are so fascinating is that they are a rare cosmic coincidence. The sun is about 400 times larger than the moon, but it's also 400 times farther away from Earth. This perfect ratio allows the moon to appear almost exactly the same size as the sun from our perspective, creating the conditions for a total solar eclipse. Over time, this will change as the moon slowly moves farther away from Earth, and total eclipses will no longer be possible. We live in a unique time in the history of our planet when these celestial events can occur. The longest solar eclipse on record. The longest total solar eclipse on record occurred on July 22, 2009, and lasted for 6 minutes and 39 seconds. This eclipse was visible across parts of Asia, including India, China, and Japan, and it provided a rare extended view of totality. While most eclipses last only a few minutes, this event gave scientists and enthusiasts an exceptional opportunity to study the sun's corona and the Earth's atmosphere during an eclipse. The duration of an eclipse depends on various factors, including the distance between the Earth and Moon and the speed at which the Moon's shadow moves across the planet. Eclipses and ancient calendars. Many ancient civilizations used solar eclipses as part of their calendar systems. The Babylonians, for example, were able to predict solar eclipses by tracking their occurrence over long periods of time. The Maya civilization also had advanced knowledge of eclipses, and they incorporated these events into their calendar and astronomical observations. By carefully observing the cycles of the moon and sun, these early astronomers could predict when the next eclipse would occur, helping them plan religious ceremonies and agricultural activities. Eclipses on other planets. Solar eclipses are not unique to Earth. Other planets in our solar system experience eclipses as well. For example, on Jupiter, its moons regularly pass in front of the sun, casting shadows on the planet's surface. These eclipses are frequent due to the large number of moons orbiting the gas giant. On Mars, the tiny moons Phobos and Deimos occasionally pass in front of the Sun, causing brief but interesting partial eclipses. While these events are not as dramatic as solar eclipses on Earth, they offer valuable opportunities to study the dynamics of planetary systems. The role of gravity in eclipses. Gravity plays a crucial role in the occurrence of solar eclipses. The gravitational pull of the Moon keeps it in orbit around Earth, while Earth's gravity keeps us in orbit around the Sun. The balance of these forces creates the conditions for the Moon to occasionally pass between the Earth and the Sun, resulting in an eclipse. Understanding how gravity influences the movements of celestial bodies helps astronomers predict future eclipses with great precision. This same gravitational dance is responsible for the tides on Earth, another reminder of the interconnectedness of the Sun, Moon, and our planet. Eclipse myths from around the world. Throughout history, different cultures have created myths to explain the occurrence of solar eclipses. In Norse mythology, it was believed that a wolf named Skjöll was chasing the sun, and when he caught it, an eclipse would occur. The ancient Greeks believed that eclipses were a sign of the gods' anger, and that they foretold the downfall of kings or nations. In Hindu mythology, an eclipse is caused by the demon Rahu, who tries to swallow the sun but fails because his head is cut off, leading to the brief disappearance of the sun. These myths highlight humanity's attempt to make sense of this rare and mysterious event. Eclipses as a tourist attraction. In recent years, solar eclipses have become major tourist attractions, drawing visitors from around the world to specific locations where totality will be visible. Countries and cities within the path of totality often see a surge in tourism as people flock to witness the rare event. Solar eclipses as a boost to local economies. The tourism generated by solar eclipses provides a significant boost to local economies in the path of totality. Hotels, restaurants, and travel services often see increased bookings, and many towns host special events to accommodate the influx of visitors. In some cases, local governments and businesses coordinate eclipse festivals, offering entertainment, lectures, and public viewing areas to enhance the experience. The economic impact of an eclipse can be substantial, turning small, often rural, areas into temporary hotspots for tourism. For many communities, the event represents a once-in-a-lifetime opportunity to showcase their region on a global stage. Eclipse viewing from space. Solar eclipses have been observed from space using satellites and spacecraft. NASA's Solar and Heliospheric Observatory, SOHO, and the International Space Station, ISS, have captured stunning images of eclipses from their orbits. Viewing an eclipse from space provides a unique perspective, as astronauts can witness both the moon's shadow moving across Earth and the sun's corona without atmospheric distortion. Space-based observations have significantly advanced our understanding of the sun's outer atmosphere and its interaction with the solar wind. These perspectives allow scientists to capture data that isn't easily accessible from Earth's surface. The changing path of totality. The path of totality for solar eclipses is not fixed. It changes slightly with each eclipse due to the moon's varying distance from Earth and its slightly tilted orbit. The shape of the path can also be affected by the Earth's rotation and curvature. As a result, no two eclipses have the same path, making each event unique in terms of the locations where totality can be observed. Over centuries, the path of eclipses has shifted across the globe, with some regions experiencing more frequent eclipses than others. This variability adds to the excitement and challenge for eclipse chasers. Eclipse-related scientific discoveries. Throughout history, solar eclipses have led to significant scientific discoveries. One of the most famous examples is the confirmation of Einstein's general theory of relativity during the 1919 eclipse. Other discoveries include advancements in our understanding of the sun's atmosphere, the discovery of the element helium during the 1868 eclipse, and improvements in solar imaging techniques. Eclipses have also provided opportunities to test new technologies and instruments, contributing to major breakthroughs in both astronomy and physics. Each eclipse offers a chance to learn something new about the universe. Predicting future solar eclipses. Thanks to our advanced understanding of orbital mechanics, astronomers can predict solar eclipses with incredible accuracy, even centuries into the future. The predictable cycles of the Moon's orbit and the Saros cycle, which repeats every 18 years, help astronomers calculate the exact date and location of future eclipses. Modern computer simulations take into account the complex interactions between the Earth, Moon, and Sun, allowing for precise predictions of eclipse paths. These predictions are vital for eclipse chasers and scientists alike, as they enable detailed planning for future observations and expeditions. Eclipse viewing parties, a social event. Solar eclipses are often celebrated with viewing parties, where communities gather to watch the event together. Schools, universities, science centers, and public parks often organize group viewings, complete with telescopes, educational talks, and entertainment. These events provide a fun, social atmosphere for people to experience the eclipse while learning about the science behind it. Viewing parties are particularly popular during total eclipses, where the spectacle of the sun disappearing creates a shared sense of awe. For many, participating in an eclipse viewing party is a memorable, once-in-a-lifetime event. Solar eclipses in ancient Egyptian astronomy. The ancient Egyptians were skilled astronomers, and solar eclipses played a role in their understanding of the cosmos. While there is no direct evidence that they could predict eclipses, records show that they observed and documented these events. Eclipses may have influenced their religious beliefs and rituals, as they viewed the sun god Ra as a central figure in their mythology. The temporary disappearance of the sun during an eclipse could have been seen as a powerful divine event. These ancient observations contributed to the rich history of eclipse studies in early civilizations. The connection between solar and lunar eclipses. Solar and lunar eclipses are closely related, often occurring within weeks of each other. This is because both types of eclipses happen when the Earth, Sun, and Moon align, with the key difference being the position of each body. A solar eclipse occurs when the Moon is between the Earth and the Sun, while a lunar eclipse happens when the Earth is between the Sun and the Moon. The Saros cycle connects these events, predicting the recurrence of both solar and lunar eclipses at regular intervals. For eclipse chasers, this means that a lunar eclipse often follows or precedes a solar eclipse. The psychological impact of solar eclipses. Witnessing a solar eclipse can have a profound psychological effect on people, evoking feelings of wonder, awe, and sometimes fear. The sudden darkening of the sky and the rare alignment of celestial bodies create a sense of connection to the cosmos. Some people describe the experience as deeply spiritual or transformative, as the brief moments of totality allow them to reflect on their place in the universe. The emotional response to an eclipse can vary, but for many, it's a once-in-a-lifetime experience that leaves a lasting impression. The future of solar eclipse exploration. As technology continues to advance, the future of solar eclipse exploration looks promising. New telescopes, space missions, and imaging techniques will allow scientists to gather even more detailed data about eclipses and the sun's behavior. In the future, we may see eclipses from entirely new perspectives, such as from other planets or through the eyes of autonomous spacecraft. Additionally, virtual reality and augmented reality technologies may enhance the experience of viewing eclipses, making it possible for more people to witness these events in innovative ways. The next generation of eclipse explorers will have unprecedented tools at their disposal to unlock the mysteries of the sun. And there you have it. We've explored the science behind solar eclipses, from how they occur to the different types and the importance of safety when observing them. These celestial events remind us of the intricate dance happening in our solar system, a dance that we are lucky enough to witness from time to time. If you ever get the chance to see a solar eclipse, make sure you're prepared, because it's an experience you won't want to miss. Now that you've uncovered the fascinating science behind solar eclipses, it's time to take action. Mark your calendars for the next eclipse, gather your viewing gear, and plan an unforgettable experience. Whether you're watching from home or traveling to the path of totality, make sure you're prepared to safely enjoy this breathtaking cosmic event. Don't miss the chance to witness the wonders of the universe in action.